Welcome, Mindsetters. You are tuned into Q&A Live. I'm your social media presenter, Megan, and we're going to be doing some physical sciences today, guys. If you don't know where to catch us, it's facebook.com/learnextra. And if that still doesn't work, we have a Twitter page, which is also @learnextra. And still, if you guys can't get through to us or you just have any other general questions, send them to questions@learn.co.za. You can also use the hashtag Q&A Live, and we'll find you on Facebook. I'm on right now. I see most of you have already responded to lots and lots of our questions. Shout out to Kid Fury. He's been quite a regular on this show, so we're super proud. And just want to send a shout out to my mom and dad watching at home. But I'm here with Tracy, my favorite physical sciences teacher. How are you?
I'm fine, thanks. I bought the sexy voice. Yeah, I bought the sexy voice today. I thought we'd try to get some attention.
It's game over.
Yeah, I know. I was just thinking, we'd try something different. Maybe if you sound a little bit different, we'll keep more attention.
Definitely.
So to Megan's mom and dad, I don't normally sound like this.
It doesn't sound like this hoarse voice.
That's my sexy voice.
I
What's
get
the
you.
problem?
And she's wearing black and I'm wearing white. We're yin to yang right now. So we're going to be doing, what are we doing today, Sam?
A revision of mechanics. So
nice.
Vertical projectile motion, momentum, impulse.
Okay.
All of those sort of things.
Awesome. Yep. She's going to go through the questions or one question that we've posted on Facebook, and then she'll come back to it a little bit later. All right, guys? But let's get going into our show. And hoi, Tracy.
Okay, so the question we've put on Facebook is from Martin. Thank you, Martin. And it says, a calf mass 1,400 kilograms travels in a horizontal road with a friction of 400 newtons and 3,800 newtons for brakes. Calculate the net force, the acceleration of the car, and how long it takes the car to stop if its initial velocity is 15 meters per second. So some important information here. We've got mass, we've got a couple of forces, and they want net force, acceleration, and then how long it takes the car to stop. Be careful with question C. It is a little bit of grade 10 equations of motion, but there's nothing to say that you can't have equations, horizontal equations of motion in grade 12. Okay, so Martin, nice question. It's deceptively simple, so hopefully you guys will all be okay. All right, so while you guys are thinking about that, let's move on to the next question. So this is from Ananti. A ball of mass, 200 grams, there we go, is dropped from a height above the ground onto a hard floor and then rebounds to a height of 22, okay? If the ball is in contact with the floor for 0.02 seconds, calculate the average force exerted by the floor on the ball. So what they're telling us is we've got a ball. Well, I don't even know why I'm drawing these things. I'm doing strange things today. Anyway, so a ball is dropped, bounces, and then reaches a height again of 22 meters. And they tell me that the ball has a mass of 200 grams. So let's just change this straight away to 0.2 kilograms. It's in contact with the floor for 0.002 seconds. And they want the force exerted by the floor on the ball. Okay, so now we look at what we've got here. And sure, I'm not actually even sure I've got enough information. Because in order to have, I have to have net force equals mass, change in momentum over change in time. So I need to know, sure, I think I'm actually, in fact, I'm pretty sure I don't have enough information because knowing that it rebounds to a height of 22, I can work out the velocity that it left the floor from. Okay, guys, I didn't see these questions before I came in today, so just bear with me. I think there might be a problem. We might have to make some changes here. I might need to add some stuff. Unless, of course, Ananti, I'm pretty sure I'm saying it wrong. Sorry.
Ananti.
There we go. Thank you.
All good.
If you're watching and you want to just relook at the question, I think there's a problem with the question, but it's all right. We'll carry on as we go. To find m delta v, I need to know the velocity with which the ball hit the ground. So I need to know the velocity it hit the ground with, and I need to know the velocity that it left the ground with, okay? Now, the velocity it left the ground with is easy because I know the height it goes to. So if I'm going to go, this is the up motion, I'm going to make down positive, okay, because that was my original direction. And for the upward motion, my final velocity is 0. My initial velocity was, well, we don't know. I'm going to work that out. My acceleration is 9,8 because it's down. And delta y is minus 22. Now, I'm making delta y minus 22 because it's moving up, okay? It's above where it was. It's going upwards. So I want VI. Best equation for this one is, and I'll try not to keep moving the screen around, okay, is going to be VF squared equals VI squared plus 2A delta Y. VF is 0. VI is what I'm looking for. So that's 2. This is 9,8. Now, if you didn't make delta Y negative here, we would have been in a bit of a pickle because you would have ended up trying to square root a positive number. Okay, so if we go here, because I can't do this in my head, that much I can tell you, not today. So 2 times 9,8, no, 9.8 times 22 gives me 400, and so VI squared equals 431,2, which I need to square root. Okay, which is 20,77. So 20,77. Okay, now let me tell you where my problem is at the moment. Is I'm looking at the information given to me, and I actually don't have enough information to work out what force it hit, well, what its velocity was when it hit the ground. Because if we look at the downward motion, okay, and we go, I know VI, it's 0 because it was dropped. VF, I don't know. A is going to be 9,8. That's an A. No, that doesn't even look like an A. Let's make it look like an A. So apparently not only is the voice gone on strike, but the hands as well, but don't tell anyone. Delta Y and delta T. Now, if you look at those equations, I simply do not have enough information. So we're going to have to add something here, all right, because there's no way I can do it without that. So I'm just going to make something up.
Random, okay.
If that's okay. Anati.
Anati.
Sorry.
It's okay. It's Monday.
Anyway, if this was a question you got in class, I would go back to your teacher and ask her what the height was, unless there was a diagram. Perhaps you didn't give us the diagram. I don't know. All right, so let's say, I don't know, let's make it go from 30 meters, not there, 30 meters, okay? It's definitely an elastic collision, so let's say it drops 30 meters, okay? So if I now wanted to find VF, I would go VF squared equals VI squared plus 2A delta Y. So this is 0 plus 2 times 9,8 times 30. So I know my substitution's right because I'm not trying to find the square root of a negative number. Okay, times 30 gives me 588, which I'm then going to square root. Okay, there we go, 24,25. Okay, so, all right, now, this was the up and this was down. Now, that was the motion of the ball in two parts. What they wanted was what is the force that the ball experiences. So if I go back here and I say, well, the ball hits the ground at 24, what was it? Sometimes paper's easier, 24,25 meters per second. Then it left the floor at 20,77. And the time that took was 0,002 seconds. I've now got enough information to work out F net. Right at the beginning of this question, I chose down as positive. So that's plus, that's minus, that can't change. So if I now go, well, F net equals m delta v over delta t, so that means it's mass and it's final velocity minus initial velocity. Okay, the mass was 0.2, because it's 200 grams, yes, so it's 0.2. Final velocity was minus 20.77. Initial velocity was 24.25. And I'm going to divide that by 0.002. Okay? Now let's put that in the calculator because I absolutely can't do this in my head. So that's 0.2 times minus 20.2777 minus 24.25. Okay, divided by 0.02. No, I didn't want that. Who knows what I'm doing? Minus, I've got a nice number. Okay, what does that minus tell you? The question asked you to calculate the average force exerted by the floor on the ball. Well, the floor's got to push up. So that's fine. It's a negative answer. It's exactly what I wanted. So therefore, it's 4,502 newtons up. That's actually quite a difficult question to do without it being split up into parts. Generally speaking, they tend to split questions like this up and ask you for different points, but to go straight from this to the end, this is difficult. And this would be worth a lot of marks because you'd have to do this calculation, so this would be 1, 2, 3. You have to do the calculation again, so that's 4, 5. Then this would be 6, 7, 8 marks. That's a lot. But there was definitely something missing, so I just made it up as we went along. Okay. Ooh. I wonder. Okay, so let's see how you're doing, because now we got back to Martin's card. Yeah, we can start it, hey?
Which one? Facebook?
Yeah, the Facebook question. Or do you think it's too early? Have we got any?
We've got answers.
Let's see how we're doing. Okay. Even if we can just do the first one.
Okay, so I don't know if they're right, but let's check.
Okay.
Innocent says the F net is 3,400 newtons. Wrong, right?
Okay, I know where he's got it.
Kid Fury also said 3,400.
Okay.
Just checking. Some people sent in pictures. Thank you. That would be Anita and
all right, I think you've probably trying to draw some sort of force diagram. Yeah. That's great.
It is, yeah, everyone gets 3,400. Yeah.
Okay. In a way, I'm glad you've got it, and in a way, I'm not glad you've got it. So, and I think it's also because a lot of you aren't driving yet. That's where where this has got to make sense. So, let's remember, first of all,
always draw.
Yes, and I can't. So my drawing is worse than my voice at the moment. So
all good. Just rough little sketches. Just
go with it, okay? So here's our car, okay? And it's a box car from the 80s.
It's awesome.
Okay, so there's my car, and there's,
the window.
The window, car's going in this direction, okay? Now, with the car going forward, what you need to recognize here, guys, and this is where you're getting confused, is the car's going forward, friction always opposes motion. So the friction must go backwards at 400 newtons, okay? But they're wanting to stop the car, so the driver puts their foot on the brake. The brake is also opposing the motion, okay? There's nothing actually pushing the car forward. When you're driving, this is what you'll learn. It's all about clutch control. It's great. And when you're braking. So when you brake, you always use your right foot for both your brake and your accelerator, because you can't brake and accelerate at the same time, because then your car's going to get very confused, okay? Your accelerator pushes the car forward. The brake pushes it backwards. Now, if you take your foot off the accelerator, your car's not going to stop still straight away. And if it does, you are probably on a really steep hill, okay? And there's something wrong. It shouldn't happen. So your car's going forward, even if it was going forward and you take the foot off the accelerator, it's going to keep going forward. So the brakes oppose the motion. Brakes have to slow it down. Friction also always opposes motion. And I think what you guys have got a little confused here is you've gone, brakes is an applied force, friction must oppose the applied force. It doesn't oppose the applied force. It opposes motion. So sometimes your applied force and your friction can help, okay? That's a good thing. So for your net force here, my net force is actually going to be the force of the brakes plus the force of friction. So in fact, my net force here is going to be 3,800 plus the 400, which gives me 4,200 newtons. But remember, it's got to be a net force, so it's got to be backwards. That's really important here. Okay, now I think because a lot of them got that wrong, because you minus the 2, I think what we're going to do is let's take a bit of a break, and then you've got some time to fix your answers for the next 2. Otherwise, I think it's a bit of a waste. So,
all right, guys, just have a look. Yeah, have a look on the Facebook page. We'll be commenting and looking at your answers again, and we'll see you right afterwards. Welcome back, guys. Hope you had a nice ad break. You got some water and you're feeling refreshed, because we are not even halfway with our show yet, okay? Well done on answering on the Facebook page. And if you've just tuned in, it's facebook.com/learnextra. And we're doing the question. We're going to do part B and C now with Tracy. So let's hoy.
Yeah. Now, before the break, we realized that quite a few of you, and we're grateful that you did, got the wrong answer to A. So, and Megan's having a good giggle because she's not quite sure what to do there.
Yeah.
She got it wrong too. It's fine.
It's all good.
It's all in it. She's a blonde after all. Anyway,
no comment.
No, we won't go there. Anyway, so, but what would happen in an exam if you got part A wrong, but now you use that answer correctly in part B and you use it correctly in part C, you get the marks for B and C, okay? You only lose the marks once, and that's in part A.
Well, that's convincing enough.
Well, that's fair. Otherwise...
At least, because if I was sitting there and I got A wrong and then I know B and C are going to be wrong, you know.
Yeah,
at least it's motivating.
But it's fair. It's like you can't get penalized 15 times for the same mistake.
Yeah.
Unfortunately, it doesn't always work like that in chemistry. Chemistry, you tend to get penalized a lot. But we don't see the point. We're also testing, and a lot of times you make a mathematical mistake.
Definitely.
So why should you get penalized 15 times because you made a maths error? It's not a maths exam.
Yeah.
But you got to use it correctly. So for those of you who got A wrong, look at how I'm doing B and check that you did it the same way, just with different values. Then I'm happy. Then you're on the right track. Okay, so we found out before the break that my F net was 4,200 newtons backwards. Okay. So now they ask you to calculate the acceleration of the car. Now, this is Newton's second law. So this is F net equal to MA. Be careful here now. Okay. By default, we've made forwards the positive direction. Your F net is backwards. Must be negative. Okay. My mass is 1,400. So now I want A. I'm going to go 4,200 divided by 1,400, and I get 3. But watch, I'm going to get minus 3. So now that's a big thing for me. Guys, that negative is important because I'm pushing brakes and I've got friction. That means I've got to slow down. My acceleration has to be in the opposite direction. Has to. It must be negative. So be careful. If you substituted, even if you had the wrong answer in A, if you made that a positive 4,000 or 3,400, you've made a mistake again. So please be careful. So this means it's 3,000, not 3,000, that's ridiculous, 3 meters per second squared backwards. Okay, great. Now we get to the last one. Hopefully we're all okay with that, all right? Now they say, how long will it take the car to stop if its initial velocity is 15? So now what they're telling us, initial velocity, 15 meters per second. Final velocity is 0. Why must my acceleration be negative? Because if I put a positive acceleration in here, I'm going to get a negative time. You cannot have a negative time. Okay, be careful. And I want time. So we're going to use VF equals VI plus A delta T. So VF is 0, that's 15. I'm happy to say that my brain isn't completely asleep today.
Yay!
So I can do this one in my head. Okay.
That's good.
Great.
There is light at the end of the
There's
tunnel.
5 seconds. Okay. Now, if you'd got your acceleration as positive, you would have tried to find a negative time. Guaranteed, if you do a calculation that ends up with a negative time, you have made a mistake. Time is a scalar. We can't go backwards, okay? No matter how nice that movie was that you saw last night that you'd really like to watch again, okay? And plus it was Sunday and you didn't have to go to school, you know. Or, gentlemen, how nice that girl is that you were sitting next to yesterday and you were just like, ooh. Sorry, you can't go back in time. You should have used your opportunity when it was there. You know, I'm just saying. It's
just
one of those things.
Holla.
Yeah, you can't go back in time. Time must be positive.
Definitely.
Okay, so it really wasn't so bad. We made a bit of a boo-boo at the beginning. It's all right. We now move on. Okay. Now, this pleasure. I'm not sure this question's a pleasure.
Yeah. For pleasure.
Yeah, I feel for you, sweetie. Because I saw this question when I arrived at the studio this afternoon and went,
damn.
Thanks. Anyway, because the brain's not working so well, but it's all right.
Shame.
Imagine what's been taught by me in the last couple of days. It's been like...
It's okay.
It's been like this
That's
for
acceptable.
a week, by the way. It's okay. My kids just laugh at me now. Anyway, so, pleasure. I'm going to try. Okay. The graph below shows how the momentum of car A changes with time just before and just after a head-on collision with car B, okay? Car A has a mass of 1,500 kilograms, while car B has a mass of 9, so that's probably important, okay? Car B was traveling at a constant velocity of 15 kilometers per second west. Take east as positive and consider the system as isolated. Now, you cannot change the sign convention. That means car B's velocity has to be negative. You cannot change that. If you don't use east as your positive direction, they will mark you wrong. Okay? Guaranteed. There we go. So, here's the graph. Ooh, look, it's such a pretty graph. Doesn't really fit on the page, though. Anyway, so here's the graph, momentum. And we look at it and we go, well, that's a nice... It's momentum in kilogram meters per second, time in seconds. First question is, what do you understand by the term isolated system as used in physics? Such an important question because we only deal with isolated systems, and what that means is there are no external forces. Okay? And by external forces, we mean friction, mainly. Okay, and also with things like a car collision, we assume that neither of the drivers put their foots on the brake, which I'm hoping once you learn to drive, you'll realize is actually a good way to avoid a collision is actually to brake. All right, just don't keep putting your foot on the accelerator. Or we're also assuming things like, for example, with modern cars, they're designed to crumple, but there's an extra external force on it because they crumple and the engines drop. So we assume all of that's gone. So there's no external forces, no friction, nothing like that, okay? Then they say to us, use the information above to calculate the velocity of A just before the collision. Okay, so now we've got to look at this and we go, well, I know car A's mass, okay, but this, no, that's not what I want. Come back here. There we go. This is what I need to use. Okay. I know that car A's momentum before the collision was 30 times 10 to the 3 kilogram meters per second east. How do I know that it's east? It was positive. Straight off the graph. Okay, so for the first one, that's easy enough. So we're going to go, well, initial momentum of A is going to be the mass of A times its initial velocity. In fact, this was only worth 3 marks, so it's actually quite easy. So this is 30 times 10 to the 3. A had a mass of, I'll tell you now, because I've got it on paper, makes it easier for me, 1,500 kilograms. All right, so I'm going to go 30 to the 3 divided by 1,500 is 20 meters per second. That's okay, it wasn't going too fast, but it was going east. In fact, I don't need that. I keep doing that. It said magnitude, so I just needed the 20 meters per second. If you put a direction when you ask for magnitude, it's really not a problem. What you do need to remember, though, is if you ask for magnitude, it must be a positive answer. So even if you get a negative answer along the way, you must change it to positive. Okay, so now we know what A's velocity was. Great. Okay. Oh, still same question. Oh, lots of reading. And there we go. And let's just remind ourselves that initial velocity was 20. Okay. All right, so now it says, the velocity of B just after the collision. Now, this was worth 5 marks. Guys, what have I got here? I know the velocity of B before the collision. Okay, just me and this board today. Here we go. Board doesn't like my sexy voice. We said that was minus. So I want the velocity of B after the collision. I need a little piece, and I need an extra piece of information. And in fact, be very careful with this question. This question won't be a carry down, okay? So if you got...
Won't be a what?
A carry down.
Oh.
So if you got the last question wrong...
Oh, gosh.
They won't actually carry that answer down because you don't need it.
Mm-hmm.
I know initial momentum of A. It's 30 times 10 to the 3. I know final momentum of A, and this is going to be, okay, it wasn't marked on this graph, but actually it's 14, so just believe me on this.
Take your word for it.
It's on,
Okay, all right.
It's on my piece.
She's just proving.
Just saying?
Just saying.
Promise there's no answers on this, just so you know, it's not my cheat sheet. Okay. Some days I wish there were answers on it. This just keeps me on my toes.
All good.
All right. So, I know this is why if you get the first one wrong, they won't carry it down because you don't need it. However, probably if you get one wrong, you probably don't understand the question in the first place. So, remember to do B. Total momentum before equals total momentum after. Okay, so we would go MA/VIA plus MB BIB. Afterwards, they're two objects, we're assuming. I don't know. I'll be able to tell after this. Oh, that should be an F. That should be an F. Okay. Now, from the graph, I know that that's 30 times 10 to the 3. They told me that B had a mass of 900. Now, be careful. It was going west, so it's minus 15. After the collision, A was 14 times 10 to the 3, and I don't know B. That's the science. Now it's a maths problem, okay? So we'll have 30 times 10 to the 3 minus, and this is going to be 900 times 15, okay, 1,301, or 13,500 either way. Okay, I'm going to minus the 14 here. So it gives me 900. Okay, so this gives me 30,000. 1, 2, 3. No, that's not it. 3. No, that's 30,000 minus 13,500. minus, all right, okay, let's do this. 30 to the 3 minus 13,500 minus 14 to the 3 gives me 2,500. Okay, so VB, so now I'm going to take that and I'm going to divide by 900 and we get 2,78 meters per second, but it's a positive value, so it's going east. Please be careful, this one I did need to give, I absolutely needed to give my direction because it didn't say magnitude of the velocity, they said velocity of, and I get a positive answer, so it must be going east. Okay? That was a horrible maths question, but the reason why there wouldn't be a carry down is because you didn't need to know VI, the initial velocity of A, to get the initial momentum of A. Okay, so just be careful. Now they say to us, calculate the magnitude of the net average force acting on car A during the collision. Guys, this is not dependent on anything that you've worked out up till now, which means there's no carry down. So remember, net force is change in momentum over change in time. Now, I wrote change in momentum as m delta v earlier. I'm not writing m delta v like that again because I'm got to use the momentum from the graph, okay? Change in momentum is final minus initial. So final is, what if I growl at it? It'll be happy. Okay, try again. There we come. Okay. You have to be nice to technology. It's going to take over the world one day. I'll hopefully be dead though.
Okay. Me, well, not
Fine.
me
No,
too.
I think it might.
I was like,
You'll be old. Anyway, final, initial. Okay, so I know I'm going to have to go 14,000 or 14 times 10 to the 3. Let's just put it as it. Oh, what am I doing? No.
oh, goodness. Lost. Yeah, there we go.
No.
Success. Down.
No.
It's okay. We are loving today.
She shouldn't make me laugh.
She's gonna choke. You're making me cough now.
Yeah, and then the poor sound guy is gonna kill me. Okay, you see, minus 13. But now, time. So now we go back to our graph and we go, it's 20,2. Final time minus initial time. Okay, so watch. I definitely can't do this in my head.
No.
14 minus 30. Okay, so I've got minus 16,000. That has to be divided by 20.2 minus 20. I could have done that in my head, but I don't want to. Look at that. Minus 160,000.
That sounds wrong.
It does. It's right though.
I know. It just sounds weird.
It sounds. I know it does. Now they wanted magnitude, so please.
That's why the negative is important.
And you take it away. What the negative actually tells me is that the car experiences a force of 160 newtons. Now remember, your car to have such a big change in momentum. And if we look at car B went from 15 meters per second to 2.7. That's huge. And car B actually changed direction altogether. So that's a very, very, very big change in momentum. Okay, and at 160,000 newtons happening in 0.1 second, that's enough force to kill you. Okay. Essentially. So that's time for a break.
Okay. Time for a break for us too. Okay,
yeah.
Guys. We'll see you now. If you have any more questions, I'm loving them on Facebook. And I'm going to ask Tracy to have a look at them now, okay? We'll see you right after the break. Welcome back. Hope you had a nice ad break again and you're ready for the last segment of Q&A Live. If you don't know where to find us, it's facebook.com/learnextra. If you want to find us on Twitter, it's @learnextra. And if you have any other questions that you want to send us, questions@learn.co.za. Tracy's just having a mini heart attack here, dying, and I'm kidding. She's okay. She's okay. Just joking.
I heard all that love and that.
Yeah, you heard. You know.
Thanks.
And I'm really loving all your questions. Tracy and I will answer them. We're going through them as fast as we can, as swiftly as we can. Some of them we will ask if we have time. Okay. So let's get started.
I just want to go back. You said it was Kid Fury.
Yes.
Hello, sweetie.
He's back.
He's back. I love it.
He said, what if we find the time by using Newton's second law for C in terms of momentum?
Kid Fury, I am more than impressed. I have to be honest that you wanted to do it this way, because that would not have been my first thought. My first thought was the equations of motion, and there's nothing wrong with what you want to do. So you're saying to me, you wanted to do it this way, where F net equals M delta V over delta T. That's fine. You need to be careful with your substitution though. Remember, F net we said was 4,200, but it's minus 4,200. The mass of the car was 1,400 kilograms. Final velocity is 0. Initial velocity is 15. And you want delta T. Now, if you forget to put the minus 4,200 in, you're going to get a negative time. But what this means is we're going to end up going 1,400 times minus 15 divided by minus 4,200. So let's see if we get the right answer. Okay, I'm going to, oh no, that's the one that comes, I don't have to put the negatives in.
All good.
I know, we'll just make it up as we go along. And look at that.
Yay, well
5
done.
seconds. Okay, so either way is accepted. And now that I'm looking at it, more than likely the examiner was expecting you to use this method rather than the equations of motion, because that's from grade 10. Either way is fine.
Can I ask another question quickly
Yes.
on that? Monwabisi says, those who said F net is 4,200 newtons, friction force doesn't it oppose motion of an object?
It is opposing the motion, but remember you're also applying the brakes. So the car's moving forward and brakes are stopping it from moving. So friction is actually helping the brakes, which we're all grateful for in a car. Okay, so friction is helping our brakes. If friction was opposing the brakes, then your car would actually keep moving. Friction would be irrelevant on a road. So your friction has to be helping your brakes in this case. All right, and I know it feels weird that friction and your applied force are in the same direction, but you got to remember that friction opposes motion, not a force. Okay, that's the key there. It's got to oppose the way the object's moving or wanting to move.
Okay. Do you want another question, or you want to go to question 4?
Let's do one quickly. One more.
Okay. It's got nothing to do with the question,
okay.
but it's what is the difference between impulse and change momentum from Brian?
Brian, impulse is equal to change in momentum.
Nice. Done.
Yes.
Case closed.
And the units are different. Impulse is Newton seconds and momentum is kilogram meters per second. That's it.
Okay, thank you.
Basically.
Thank you, Tracy.
You are so welcome.
Moving on to question 4.
Next question. Sweet Pea, I don't even know how to start saying your name.
What's the name? Nzalama. There we go. Thank you.
I got corrected, but it's still not
Nzalama.
Yeah, that's I directed today, and I'm still like, I'm not going to butcher your
You
name,
have to
sweet.
give it that flair. Nzalama.
Okay, now she's just showing off. Okay?
No, I'm kidding.
Anyway,
I'm kidding.
So, anyway, sweetie, we have changed your question a little bit, and I'll tell you why in a second. We haven't changed the numbers. We just changed a little bit, and I'll tell you now. It says, dancers have to learn many skills, including how to land correctly.
Yeah. I was a dancer, just adding my side note.
No,
there.
me too. You
Just
didn't say
adding.
no, but I was many moons ago.
Many moons, both of us.
Yeah, mine's more than yours. Shh. Anyway, a dancer of mass 50 kilograms leaps into the air off a raised platform. Now, this is what we added, off a raised platform, and lands feet first on the ground.
Sure.
She lands on the ground with a velocity of 5 meters per second, and as she lands, she bends her knees and comes to a complete stop in 0.2 seconds. Now,
Nzalama. Every time you want to say her name, I'll just
we'll just, yeah, anyway. Sweetie, we had to add in this off the race platform because in order to be hitting the ground with a velocity of 5 meters per second, she needs to be seriously high, okay? And as much as I've watched dancers, can't think of a single dancer who can get high enough off a straight jump. So possibly she was supposed to have been off a trampoline or whatever, but if a race,
Trampoline.
maybe off a trampoline, who knows? I don't know.
Maybe she was on those little blocks, you know.
I don't
And she
know,
just leaped.
but needed to be off a race platform, okay? It's not changing the essence of the question, but when we look at questions like this, as science teachers, we get a little like, it's got to make sense. It's got to be...
She can't have it not be making sense.
It's got to be semi-realistic for me. It's otherwise, I think you guys get just the weirdest idea of what's happening, okay? So now, they say, how high above the ground, okay, was the dancer at the highest point before landing? Okay, so let's just see what happens here. Okay, this is a vertical projectile motion. We know, so she's going to land. Okay, I'm going to take down as positive. Okay, her initial velocity we don't know. We'll come back to that. VF is 5. Okay, A is going to be 9,8 meters per second squared. Delta T we don't know, delta Y. I need a little bit more information. So now I've got to look at this and go, well, she jumps into the alpha raised and then comes down. So how high above the ground was she at the highest point? Well, she goes up and then she comes down. So at the highest point, her initial velocity over here is 0. So let's make that 0. Okay, we want delta Y. So we're going to use VF squared equals VI squared plus 2A delta Y. VF is 5. VI is 0. This is 2 times 9,8 times delta Y. Okay, so we're going to have 25 equal to 19,6 delta Y. So now we go 25 divided by 19.6, and delta Y is 1,2 meters. I guess a really, really, really good dancer could jump this height straight off the ground. And the reason why I've got a good judge of it is I'm only 1.5 meters. Sure. So to jump straight off the ground, yes, I'm short. Okay, she would probably be as high as I am off the ground now to about my hands, probably about here. Wow. That's a huge jump for a dancer, not without being lifted. Okay, obviously if she's got somebody helping her, which is always beautiful to watch, but for a dancer to jump flat off,
quite a lot of momentum needed.
Yeah, that's hard. And they don't describe how she jumps, so yeah. Anyway, doesn't matter. So she has to be 1.2 meters. There we go. Now, then, calculate the momentum with which the dancer reaches the ground. Well, that's easy enough. Momentum is mv, so she's 50 kilograms. She's going at 5, 250 kilograms, meters per second, down. Okay, I kept the velocity as positive because I said down was my positive direction. Okay. Excellent. This is going quite nice. Now it says, calculate the magnitude of the net force acting on the dancer as she lands. Now, she lands at 5 meters per second and takes 0.2 seconds to stop. So my initial velocity when she lands is 5. My final velocity is going to be 0. That's very important. The time it takes is 0.2, and they want F net. So F net equals M delta V right over T. So can you hear them screaming right now?
No!
Stop it, Tracy. You don't know what you're doing tonight. Anyway, I can secretly hear my learners going, Miss Velos loses her voice completely and doesn't come to school tomorrow. I'm coming anyway. I'm one of those.
It's okay.
Yeah, can you hear the groans? Oh,
No.
Yeah, maybe not. I'm not on drugs, I promise. So, final velocity 0, initials 5, change in time is 0.2. So this is actually going to be 50 times 5 divided by 0.2, and we're going to get a negative answer of negative 1,250, but it said calculate the magnitude. Therefore, my F net is 1,250 newtons. Okay, that's not so bad. It's still, ow, quite sore. Anyway, now, assume the dancer performed the same jump as before without bending her legs. Now, if you ever watch a dancer, this is exactly why you bend your legs. And it's not just because it looks nicer, okay? Will the force now be greater, smaller than, or equal to the force calculated? This is such an important question because F net is m delta v over delta t. You have to recognize the change in momentum is a constant. Change in momentum is constant, okay? By stopping with straight knees, she's decreasing delta t, okay? So the number at the bottom of my fraction is getting smaller, which means my overall answer is getting bigger. So how do we write this? So what we'd say is it increases. So we answer the question. Increases. Okay, now change in momentum is constant. F net is inversely proportional to delta t. Therefore, if delta t, let's put that there, if delta t decreases, F net must increase. Now, for most of you, you'd probably lose 1 mark almost guaranteed because what do you forget to write? What my constant is. Okay, you have to tell me what stays the same. And it's almost always, not always, there are few exceptions, but almost always it's delta P. And that's the whole issue of seatbelts and airbags and all of those sort of things is if we can increase the time it takes to stop, we decrease net force. This is an unusual question because this question's asking what would happen if we decrease the time. That means we increase the force, okay? And that's when you start getting damage. And it just looks jarring and horrible and stuff. And guys, the way I've written this, really, you can write it like that in your exams. Please remember, as physics teachers, we don't like reading lots of sentences. There's a reason why we taught physics and not a language, okay? I don't like reading essays. It drives me to distraction and then I get bored. Okay, I love reading, just not essays for marking. So write your answers in point form and in a logical point form, okay? Just don't write everything you know because that doesn't help you either. Okay, so, Megan.
Hello.
I'm hoping you have questions.
Yeah, I just refreshed because I knew. I saw she was like, okay, I'm finished now.
I might have run out of things to say, which doesn't happen often.
Oh my goodness. Okay, yes, we do have some questions, thank goodness.
Yes, thanks.
Let us have a look. Okay.
Yeah.
Is it possible, Rosie, thank you, Rosie, for the value of which 9,8 meters per second to be negative? So I think she worked out, that was the beginning. Yeah.
When you look at the questions where I was using the 9,8, okay, which was here, actually, I think it was in the first part of this question. Okay, let's do here. I used 9,8 here as positive because I chose down as my positive direction. Now I'm just going to do another color pen. If I chose an up as positive, then I would have put, no, I don't want to do that. This board
It's a
doesn't
struggle
like me
today. Please.
No, it just doesn't like me today.
Not you.
Okay, minus, and I would have put a minus there as well. Okay, so, and then my final answer here would have been negative. That's the only thing I changed if I chosen down as my positive, up as my positive direction. It really doesn't matter. It's up to you. I change depending on my original direction. I choose whatever the original direction is to be positive. Sometimes, like the question we got with the graph, they'll tell you east or down or up or anything's positive. Then you don't have a choice, but it doesn't matter.
Okay. Kodani says, what exactly is a net force?
Okay, net force is a resultant. So if I take an object, no, too far. If I take a box and I put a whole bunch of forces on it, and I say, what's the net force? The net force says that I take all those forces, add them together, however we do that in vector addition, and go, if I just apply that one force, it'll do exactly the same thing as the others. It's a resultant. Okay, that's all net force is. It means we take away all the bits and pieces, and we replace it with just one force.
Okay.
That does the same thing.
We have another one.
Yeah.
There's lots of questions. Lebo says, wow, okay, for acceleration, isn't it the equation of motions, or are they just used for projectiles only?
It depends on the question. So most of the time we use equations of motion, okay? And like Kid Fury said earlier, we could, instead of using, sometimes we use acceleration with F net equals ma. You have to look at the context of the question. If you're looking at a Newton's second law question, then you're going to use F net equals ma from grade 11. All depends on the question. But most of the time it's projectile motion.
Projectile motion, all right.
Yep.
And Ungani Kosi says, is there no applied force?
Not in the questions we were doing.
Yeah.
It all depends. In fact, there was an applied force. With Martin's question with the car, the brakes was the applied force. It just happened to be in the same direction as friction. That's why you got to...
It's confusing.
That's why I think you all wanted to minus
it.
Go
back. Makes sense.
Because you want friction to oppose the applied force, but it doesn't. Brakes was your applied force. Yeah, it's not always called applied force.
But, okay. All right, get it. All right.
And I think we're done.
We are done. You may say goodbye.
Bye. In fact, we don't have any more live shows on a Monday till next term. So have a good holiday. I'll have a voice next time.
She shall have a voice. And she shall be wearing non-black. Kidding, always wearing black. Thanks, Trace, for the great show. Thank you, Mindsetters. Hope you have a good rest of the day. Hope you guys enjoyed the show, Q&A live. And we'll see you again soon. Enjoy the rest of your term and have a blessed, blessed day. Cheers, guys.
Walzer Matrix 2021 Catch-Up is brought to you by the Department of Basic Education, NECT, ETDP SETA, SABC, MultiChoice, and DBE TV on OpenView Channel 122 in partnership with